I am Robert Alvarez. I'm a Senior AI Solutions Architect here at Pure Storage. Happy to be with you here for this AI Infrastructure Tech Field Day. And this is part 3 of our talks where I'm actually going to be diving into real-world insights and use cases. This is the stuff that I test. So I am an AI architect. I am not a storage architect, for example, like Hari and Boris. So I really recommend you listen to those talks where they go into the overview of the FlashBlade and into the internal workings of it. I'm actually going to focus on practical applications of AI and things that we've tested here throughout. So my agenda is kind of really talking about a lot of customers who embark on AI. Not everyone's meta building an AI research supercluster. A lot of organizations are just embarking on AI for the very first time. They have some use cases. I'm actually going to dive into a couple of those use cases, a medical imaging workflow and a RAG-powered LLM. And then quickly, depending on time, talk about some of the barriers to scaling when you don't think about storage from the get-go, from going from development or from prototyping to production. So when you're embarking on AI, most customers are saying, well, I've got a use case. I've just bought a DGX or a couple of DGXs. What do I do? They might think about storage at that onset and think about, well, what are the platform considerations? I might want something that's high performance, something reliable, simple. But I can tell you this as an AI architect, I'm like, well, there's hard drives on the DGX. Let's just stick to simple, right? It's got low latency. It works right out of the box. I don't have to worry about network configurations, but there are definitely downsides. Immediately your data siloed. You've also got problems about scalability, but let's think about this from the get-go. Let's just say for now that magically we can waive out all scalability issues with a local SSD or a local NVMe drive. But in that case, we actually can still think about the benefits that FlashBlade can bring, even assuming that you can scale local NVMe drives. So we've actually done work with NVIDIA and one of their models that does medical imaging pipeline. In that workflow, what they're doing is doing AI augmented CT segmentation. So a lot of hospitals have CT scanners. They're using this, running this pretty much 24 hours a day, especially in emergency rooms, but in other cases, they might just be working from 7 to 7, and they need to process all of those images. You want to get that image back to the doctor as quickly as possible, do things like drug tracking, organ detection, tumor detection, et cetera. So with this pipeline, you can easily pass this image through your model and get organ segmentations out. Here we're actually segmenting one of the kidneys. Now, imagine doing this at scale, where you're passing hundreds or thousands of images, depending on, and these images vary in size, depending on whether it's a segment of the body or a full body scan. And here what we've actually shown in our labs is that if you use FlashBlade instead of the local NVMe drive, you can actually get up to 40% faster inference times. Additionally, most of the time that you have that like scale on like whenever there's lags, it's almost always on the local NVMe. So if you notice here that these orange peaks show the consistency and reliability of using FlashBlade instead of that local NVMe drive. These images go in increasing size from left to right and then top to bottom. On the largest size, they're about 150 megabytes, but we're still always beating that local NVMe drive throughout a lot of our testing. Well then, what if you wanted to do model training and checkpointing? On the checkpointing side, we too also see faster checkpointing times, meaning that we can offload data off the GPU faster so that you can actually reduce the number of idle cycles that you have. You'll actually see there's two sort of curves here. There's one at the very left, one at the right. This is the difference between single GPU checkpointing and multi-GPU checkpointing. Multi-GPU checkpointing takes a little bit longer because you have to coordinate all the parameters between all of the different GPUs. And this was done over 500 different checkpoints. Each checkpoint was 850 megabytes in size. Okay. So these are sort of real-world applications that you can use and see that there are benefits to the FlashBlade just from the onset compared to what might be the simplest thing an AI architect would think of using. Now for the training and fine-tuning as a whole, because the overwhelming majority of that time is spent on the GPU itself, there's no great visual for it. But what we could actually show you is that this FlashBlade actually delivers data quickly to and from that GPU. That high-speed networking ensures that as your image sizes grow, you could consistently pass that data throughput quickly. You've got reduced time for the model checkpoints. That means that you can keep those GPUs more fed quicker. But also, because you can enable more frequent checkpointing, you can do larger hyperparameter tuning. So when you think about the load balancing, my colleague Boris was talking about, highly recommend listening to his talk about how we do load balancing. We could actually think about scaling out hyperparameter tuning and model development, model training in ways that you can't with just local NVMe drives. And you're trying to actually maximize that GPU productivity by ensuring those less idle cycles there. Now, another common use case we've been seeing lately is RAG-powered LLMs. Many organizations, obviously, with the release of ChatGPT, have been trying to get the power of LLMs within their organization. And what a lot of people don't realize is when you're using a vector database, so instead of a traditional relational database, traditional databases typically reduce data, but in a vector database, you're actually expanding your data needs. So if you think about this diagram that you see here, you've got all of your different data, typically your enterprise data. You've got relational databases, you've got corporate data, you've got audio files, video files, PDFs, et cetera. All these customer documents, they have to be passed through an embedding model. The embedding model is really that secret sauce, that LLM, that takes your documents, it puts it into a higher dimensional representational space. So things like finance documents live in one section of your higher dimensional space. Things related to customer service calls or human resources issues all live in a different section. But because that embedding model is so critical to this pipeline, that embedding model turns your census of a document into a hundreds or thousand dimensional vector that needs to be stored into that vector database. Additionally, that vector database is now going to feed that LLM, and that LLM can have human curated responses that go back into that LLM and feed additional quicker responses that say, like, this is really a great response for these information, and we can actually surface those back again to the users.
I have a question here. High dimensional representation of data will still be smaller in size compared to the actual data?
No, so if you think about the way that it works is that you're taking a PDF. That PDF gets chunked into a paragraph or into a sentence. And think about, well, how much does a sentence take up in data? And how much does a 1,224 dimensional vector take up in data?
So it's a property of chunk size. If I have a bigger chunk size,
the bigger the chunk size, the smaller the data expansion. But this is, and that's why I say this is not exactly 10x. It's a rule of thumb. It will expand your data needs.
Right.
Sometimes it could be 5, sometimes it could be 12, et cetera. But just think about it holistically. A good rule of thumb is you're going to expand your data needs by roughly 10x.
Yeah, because what I've been seeing is that actually it reduces, like even with a lot of parameters, like the highest parameter or multi-dimension is like 1500, something like that.
So ChatGPT has like a 2000 something multi-dimensional vector. Cohere does like 768. There's some things in between, but these are also going to depend on the use case. Like,
and
you might have smaller models that are focused on coding specifically instead of just like a generic, foundational model.
Right, right.
Okay. There are two workflows that we think about when it comes to RAG. The top part is the document ingestion and the pipeline going from your data to the vector database. So as we were talking earlier, we need to pre-process those documents. So that means that you take your audio, you take your images, you take your text, et cetera, you chunk them, you do all of that heavy compute power, pass them through that embedding model, and then store them into your vector database. And then you also have the user workflow. So that user is typing a question into a chatbot, similar to like we would type one into ChatGPT. That question that they ask or that query that they ask must also be embedded. That embedding model creates, that embedding model then takes that vector and says, well, what documents are related to this question? And it surfaces those for you. And then the documents that you surfaced, the question that the user asked, plus the prompt that the LLM uses, all gets parsed through the LLM, and it has to get fed back to the user. Round trip times on average for that bottom workflow is 1 second time to first token. So that's the very first time you see a character pop up on your screen. But this is a simplified workflow because in an enterprise or in a much more complex situation that enterprises tend to be running, you're going to have all of your text documents going through a data processing engine like we talked about before. You need to store that metadata. You need to store those chunks. You might be using several embedding models, some for images, some for text, some for audio. That also gets stored into a vector DB on the very far right there. Then on the bottom, you have that same user question coming in. An agent, so another LLM in a sense, is then saying, well, do I need to go and get data from somewhere else besides my vector DB? So you can actually take that query. It can take you into a relational database, do a text to SQL model. So I'm saying this person's asking about finance data. Let me go into the relational database where the finance data lies, do a summarization, do a group by, et cetera. Get that data out, pass that through the LLM, and then make sure the agent checks it for sanity, make sure that there's no hallucinations, and ultimately serves that back out. So it's a much more complex process. And where we have our storage touch points here is obviously in the data ingest. You have it obviously by storing the models, versioning of those models, all of those data chunks, hosting those models, as well as the vector databases. So this is where you want something flexible, because you got to think about, well, all of the different things that these need are going to be very important here. But no organization is going to say, I'm going to use one model to do everything. They're going to do dozens of models, dozens of use cases, dozens of applications. So when you really want to scale from dozens of users to thousands or even maybe possibly millions of users, this pipeline becomes much more complicated. You're dealing with enterprise scale data, lots of processing engine, many, many multimodal models that you're dealing with. So you truly do need a high performant, reliable, scalable storage like Pure Storage FlashBlade. So where do we actually speed things up here? Now, we've again done some work with NVIDIA where we're looking at data ingestion versus that local NVMe drive to ingest 1 million vectors into a Milvus vector database. So we were particularly working with Milvus here. And because Pure Storage FlashBlade is flexible, we can show S3 to Milvus instead of file. And by doing so, that we can actually reduce some of the bottlenecks there, and actually we decrease our ingestion time. We speed up ingestion time, by 36% versus that local NVMe. When we scale to multiple nodes, we see the same sort of benefit. Then you have one node running on the FlashBlade versus two nodes running on the FlashBlade. You see a similar, almost linear decrease in time to ingestion. And then when you're trying to serve hundreds or thousands of, or even millions of users, the number of queries that you can do per second off of your vector database also are important. And as we scale from one node to two nodes to three nodes, we actually increase almost linearly the number of queries that we can actually perform there. So to bring it back, we really think about embarking on enterprise AI differently. Because when you have many use cases and many GPUs, storage really needs to be the focal point here, where you need everything that's showing high performance, reliability, simplicity, efficiency, and flexibility. Now, when it comes to the barriers to production, I myself have been on the very far left side here many, many times, where I really typically think about a few processes that are important to me. So I've got my data preparation, so typically it's going to be curated. I work out it in silo. I'm not necessarily always dealing with a real production systems, but I've got my own little data. I do my feature engineering, do my model training, model optimization, evaluation, et cetera, fine tuning, hyperparameter tuning, et cetera. And it works. Great. Let's put it into deployment. But then comes the reality of deployment, where I need to be ingesting from real-time sources. I need to be doing versioning of my models, of my data. One thing that's very important that's not really, that's tracking accuracy there, one thing I really care about as an AI architect is making sure that I don't have what's called data drift. So that means that the data I trained on starts to look very differently from the data I'm seeing in production in my model. And there are ways for us to track that as well. So that's going to be very important. I also need to do retraining, make sure I'm using my GPUs efficiently, et cetera. But it's more than just these 6 stages, because when you think of the true AI pipeline, you really have to start with that business problem, define the data that you need to need, whether it's real-time streaming, relational databases, et cetera. You then go into your feature store system where you're offloading some of the features that your model may need. You have these parallel tracks of experimentation and production. So experimentation being more the side that I lived on, where we work when sometimes one of the challenges here is that when you have multiple AI teams working in silos, sharing of information and sharing of resources becomes really hard and a blocker to actually efficient productionizing and scaling of your models. So when we think about that journey from sort of ingestion to inference of the AI pipeline we were talking about, you know, you're going to be ingesting from SaaS apps, real-time storage, real-time streaming, et cetera. So you've got a lot of sequential reads and writes. You've got small and large files. You've got varying concurrency. The data curation side, so you're storing into Kafka, MongoDB, Postgres, et cetera. Again, a lot of sequential reads and writes, small and large files, varying concurrency. Then for your processing engine, like things like Spark, Rapids, et cetera, got sequential and random reads and writes. Small and large files, again, high concurrency. The analysis, very similar. This is where you can do a lot of random access, lots of reads, small and large files. Training, as we all know, is a very time-consuming process, lots of random access, et cetera. So you really think about all of the pipeline that you need here and all of the storage components that are necessary here to make this an efficient pipeline, and obviously ultimately inferencing there at the end.
Hi there, I'm
Yeah.
Brian. Sorry, you're just like moving
Yeah.
pretty quickly. So can I ask what these diagrams are at the bottom here? I don't know what these mean.
Just sort of like they're cartoons of the types of reads and writes that you'd be doing here. So if I were to just leave it at that, there's not much there that the cartoons are.
So do they relate to the 5 terms that are above
Yeah,
there?
in terms of the 5 terms that are right above it.
Okay.
Yeah.
Okay.
So Robert, this is Max.
Hey, Max.
Speaking. And I do have one question that might interest our viewers as well. Is we jump from basically DFMs and describing the hardware architecture into kind of the challenges and the ways you guys, do handle, AI workloads. But what I miss here, I mean, I know that because you guys brief me on a regular basis, and so do you with some of the audience here. But what I guess some of our viewers are missing is, what is the unique value that FlashBlade is bringing to the table? Is it a performance perspective? Is it from a scalability? Is it from a density perspective? Is it multi-protocol support? What's the deal breaker? I mean, why should I invest money in FlashBlade and put my money with Pure Storage rather than with another vendor, and going with Evergreen, STAS, whatever you're doing there, a pure Evergreen for AI and so on. So what's the story there? I know we have 7 minutes left, but is that something that you or your colleagues can touch on eventually?
Yeah, actually, so Max, it's an excellent question. So you kind of hit upon a few things of why it's important to have high performance, scalability. Those are all the things that should matter. So I come from the hat that I've been an AI engineer. And for me, the more simple the storage is that I'm interacting with, the more that I can actually effectively do my job as an AI engineer. So what I'm trying to highlight here is that all of the things that Hari and Boris talked about are important from the infrastructure perspective. But for me as that AI engineer, I want something that's performant, something that's reliable, scalable, efficient, without necessarily need to understand all of the inner workings. I, as an AI engineer, are very rarely thinking about the DFMs that are interacting with. I just want a platform that makes this so much easier for me to use. And hopefully what I'm trying to get through here with some of the workflows that we're showing is that there are performance benefits, there are scalability benefits to doing this without me as the AI engineer talking about DFMs and DIs.
So you as an AI engineer, what is the most painful problem when you work with data currently? Leaving aside like
silos, data silos. Trying to get data from different places becomes very problematic.
Okay.
So that's interesting because you didn't mention that until that question was asked. And if it's a big problem, then that's something that I guess you can lead with a use case, right?
Yeah, so that's what I'm about to do.
Because this is a lot, but if you if you lead with like data silos and these are the symptoms of that, then I guess.
So I'm going to skip this slide, not this one here. Sorry, this slide here with the challenges. So what I'm trying to basically highlight here is that instead of having all your data silos, you want to actually put everything here on a Pure Storage FlashBlade. Kurt?
Okay. Yeah. Oh, not a question. No, I get it.
Yeah. So should have led with this one, but yeah, I really wanted to have you all to have the different viewpoint. Like, I do AI, I don't do storage. But what I love about Pure Storage is that I don't have to think about it, and it actually enables me to do my job better by really thinking about storage as you're beginning your AI journey.
So as a consumer, like what is it you want to work with more? Is it file, object? Because this exports multiple.
S3, file object and file.
Both.
Yeah.
Yeah, for sure.
Okay.
But, like when we were showing those RAG pipelines, give me just a second, Bart. When we were showing those RAG pipelines, I was able to just connect to S3 for Milvus and actually increase my pipeline, increase my data ingestion pipeline. So I had that flexibility. That was very important for me.
Okay.
Yeah, Bart?
Okay, so I was thinking the entry point here is the protocol. So if I'm a data analyst or an architect or an end user using the application, whatever in the persona in those 6 stages, for me, I will see one storage space, and it's the protocol that will be unified.
And reducing data copies, going from one data storage to a different place, like going from one silo to another. So you basically have all of that at your availability. So you really get to serve the multiple users in an AI pipeline effectively.
Okay, but if I have NFS and if I have object storage, these are 2 different types of data. So I will always need to do an ETL or move my data from one place to the other. Or do you have file on top of object? Or no, you said that it's 2 different.
Well, we could speak file or we could speak object. So but maybe if Kari could.
But files are files. Files is not object.
I mean, there isn't necessarily a whole lot of data that flows the entire distance.
Yeah, you're not taking one thing from.
You're making changes.
Yeah, it depends on the application you're working with. Some applications are going to be faster by talking to S3, but you have all of that there on the Pure Storage FlashBlade. And well, and like I said, don't just take my word for it. We actually do power the Meta AI Research Supercluster. They build the largest open source foundation models. They use almost exclusively Pure Storage for, I think, 0.5 exabyte of flash. So what I love about Pure Storage is it doesn't matter if you need to power 1 GPU in your enterprise applications or thousands of GPUs. We're able to scale that out and still be high performant throughout the whole stages there. How big is the cluster now? Actually, that's a good question. I do not know the size of the cluster. I know that they have thousands of GPUs.
Okay, how about you guys? How big is it? How big are you on?
We have 0.5 exabyte of flash there.
Okay, I'm sorry. It's right.
So how many blades is that then?
I don't have the question for the number of blades, but maybe one of my colleagues can actually chime in.
Turn on your mic. Go ahead. Stand up, please.
Yeah.
Yeah.
So the question was how much capacity and how many blades it was in there. I think, so the answer is, I don't actually know because we've supported multiple generations. Going back to some of the earlier benefits that we allow, we've supported sort of multiple generations of these blades, which can all coexist. We spoke about the flexibility of the platform. We've changed the flash module sizes ever since we started, and all of those are able to coexist. So it's a large number of them.
Yeah, and then we also have some certification validation. So we obviously have a RAG platform, reference architecture. We've got our NVIDIA BasePod and OVX servers. And we are finishing up testing soon with NVIDIA for the DGX SuperPod. We expect that to be completed before the end of the year. So like I said, this whole little flat banners here really spread the gamut of everything that you can do just by using a Pure Storage FlashBlade, from single GPU configurations to superclusters as well. So, well, this actually was an extra slide. So yeah, and hopefully the talk sort of speaks for itself. We've got lots of customers, and we're doing very exciting things in AI. So thank you.
Thank you.